Hi, I'm Paul. We're doing Leetcode must-know interview questions. Today's challenge is search a 2D matrix. You are rating medium. You are given an m by n integer matrix called matrix with the following two properties. Each row is sorted in non-decreasing order, and the first integer of each row is greater than the last integer of the previous row, which means if you, we'll take this example here, if you read the matrix right to left, top to bottom, left to right, top to bottom, the numbers are all increasing. All right. In other words, it's sorted. Let's see, where did I leave off here? Given an integer, target, return true if target is in matrix and return false if it's not in the matrix. Let me scoot this over a little bit so we can see the whole method signature. All right, so here is the method to be written. Input is a 2D matrix and a number to be searched for in the matrix. All right. You must write a solution in O log m times n time complexity. In other words, it's a binary search. And I think what makes it medium rather than easy is it's not maybe obvious at first how to convert, well, because it's not linear. Here, let me go a little bit further with this and just say, we'll write down a couple of numbers here. No, I need a pen. Okay, so M will be equal to, hang on, don't undo the whole thing. Thanks. M will be equal to 3. That is the length of the matrix, and n will be equal to the width of the matrix, which is 4. All right? Now, as with any binary search, we're going to need low, high, and mid, or left and right. If you prefer, I'm going to say low. Low will start at 0. High will start at m times n, which is 12. And then mid is going to be low plus high divided by 2, which is 6. Okay, so what I mean is now it's maybe not obvious how to convert 6 into a row and column in the matrix. So let's look at how to do that. We'll say row equals something and column equals something. All right, the way we can get this is row would be mid divided by n, which is 4. So it's integer division. 6 divided by 4 is 1. Column is mid mod n. So 6 mod 4 is 2. All right, so then we'll go to row 1, first row, of course, being row 0. Row 1, column 2, 0, 1, 2, it's 16. And then we ask ourselves, is that what we're looking for? And it isn't. Is it less than the target? It isn't. So in that case, we have to adjust high to throw out the top half of the search space. So high becomes mid. All right, now we have 0 to 6. We got to recompute mid. 0 plus 6 divided by 2 is going to be 3. Okay? Now we've got to get row and column. So mid 3 divided by 4 divided by n. Integer division, 3 divided by 4 is 0. 3 mod 4 is, I'm going to make that into a 3. All right. So let's take a look. Row 0, column 3 is a 7. It's not what we're looking for. Is that less than the target? No. All right. In that case, we again have to change high to mid. And we have to recompute mid. So 0 plus 3 is 3 divided by 2. Again, integer division, so that would be 1. All right. We got to convert 1 to a row and column. So we have 1 divided by 4. Again, that is 0. We have 1 mod 4. And that would be, I think I'm going to have to erase that. That would be 1. So then we look at row 0, column 1, which is, as it turns out, the number that we're looking for. All right. So that's how it works, and we return true at that point. So let's look at what an implementation would look like. Actually, I forgot one thing. I wanted to look at the constraints here. So we've got m, we've got n, we've got, okay. What I wanted to see actually was if m and n, if m and n could be 0. In other words, can we get like an empty matrix coming in, and this constraint right here says no, you can't. It's it'll always be, at least 1 by 1. So okay, now we can do an implementation. So let's do this. Const m, const int m equals matrix dot size. Okay. And the next one will be pretty similar. This will be n, and this will be matrix row 0 dot size. Okay. Int low equals 0. Int high equals m times n. All right. While low is less than high, let's see. We got to compute mid. So const int mid equals low plus high divided by 2. All right. And then convert that to rows and columns. So const int row equals mid divided by n, and const int column equals mid mod n. If, what is the input called? Matrix. Matrix row column equals target return true. Okay. Let me copy that. Didn't quite work. All right, if matrix row and column is less than target, then we'll set low to mid plus 1. Else high equals mid. Okay. If we get all the way through that while loop, which ends right here, and we haven't returned true, then we're going to have to return false. All right. Let's try it. Compile error. Cons. What? Illegal start of expression. Let me see. Line 4. Why is that an illegal start of an expression? No, I got to look at that a minute. Okay. Sorry, I was doing TypeScript stuff all last night. So we'll change the const to final. Any more consts in here? All right, let's try it again. Compile error. Cannot find symbol. Oh, okay. Matrix dot. Yeah. All right. Maybe just use one language and stick with it. Length and length. Let's try it again. Missing return value. Where does? Oh, I see. True. All right, accepted. Good. I made that look harder than it really was. And submit. Study plan. All right. Well, at least we got a good time out of it. What is the complexity? It's O of n times n. I'm sorry, O of log m times n, which is what was requested. So we are good. So that's how to do a binary search in a 2D matrix. The key takeaway is it's the same as any other binary search, except that you need these two pieces here to convert mid into a row and column. So that's it. Thank you for watching. Please feel free to like, subscribe, comment, and see you next time.